Welcome back engineers, we are discussing architectural styles, and in this video let's look at the next architectural style, which is pipeline architecture. I hope you're ready. Let's get started. So to understand this architecture, let's take an example of a real world situation. Let's say we are in a restaurant, we made an order to the kitchen and the kitchen is doing the preparation and then bring the food back to us, right? So there are several steps involved in this process, and let's say the first step is a preparation phase. In this phase, the food is being washed, the vegetables are being chopped, and there is some kind of measuring happening, and whatever has been done in this step is passed on to the next step wherein the cooking happens, right? In the cooking there can be multiple steps. There can be boiling, mixing, frying, whatever it may be depending on the dish. And once the cooking part is done, the cooked dish will be passed on to the next step, which is plating. And in the plating phase, we are trying to arrange the dish beautifully in some plate and then doing some garnishing to make it even more attractive. And finally, we pass on the plate to the server, who will finally serve it to the customer, and this is called table service, right? So there are some steps involved in this. And if you observe this, there is a particular sequence in which everything is happening, and every step's output is becoming the input to the next step, right? So the prepared items are the input to the cooking stage, the cooked dish is the output and input to the plating stage, and the plated dish is the output, which is the input to the table service stage, right? So this is how a typical restaurant situation happens, and this is very analogous to the pipeline architecture style. So in this architecture, we have a couple of things, filters and pipes, which operate in a similar way that we have seen in the example before, right? So every filter is some kind of a process wherein some data processing is happening and passed on to the next layer, which is doing something else, passing to the next filter, and so on. So this is how a typical pipeline architecture looks like, right? Now let's try to go deeper into this architecture and try to understand what are the features, what is this filter, what is this pipe, and so on. So let's start. So we'll start with features. So in the features, we have pipes as the first item. And if you look at it, pipes are having two main characteristics. One is that it is unidirectional, and second is it is point to point. So when we say unidirectional, we can see this arrow, right? It is always going from left to right. So it is always unidirectional. It goes from one way to the other. This going back is not allowed in this architecture, right? So if some data point is passed through this, it always travels through the pipes from left to right, and it will end up in the last filter here. And nowhere in between we see the reversal happening. So this is not possible here. So those are the features of the pipe: unidirectional and point to point. So point-to-point communication means it takes the input from one filter and passes to the other filter. That is the only job of a pipe, okay? So that's why it is called point-to-point. Now let's see what are filters now. So each filter is a self-contained unit, okay? First thing, it is a self-contained unit. It is independent of other filters. So the job that one filter is doing will be very different from the job that another filter is doing. And it is stateless. Generally, these are stateless filters, which means that let's say one data input is coming through first filter, the second data is not reliant on first data's output and so on, right? It is always stateless. So it takes something, does something, and gives it out, right? And it does one task only. So what this means is that it has several subtasks maybe, but the primary responsibility will be only one for per filter, right? So we'll understand this when we see some examples. Now let's see the last one. There are four types of filters. One is a producer filter, second is a transformer filter, third is a tester filter, fourth is a consumer filter. So producer filter is like the first filter. So this is where, let's say, data is generated. That is the responsibility of this filter, okay? And second filter is, let's say, responsible for transforming the data. Maybe the generated data is in some raw format. We need it to be transformed into some different format to pass it on to the next filter, right? And then the third type of filter is tester filter. So tester filters just validate if the data is okay. If it is fine, it will pass on to the next layer and so on, right? So that is a tester filter. And finally, we have the consumer filter, who will actually consume the data and does something with it, okay? So these are the different types of filters, right? So let's see some examples of this. So any place where there is ETL type of situation, we can make use of this pipeline architecture. So ETL is nothing but extract, transform, and load. So which is having several steps: extract, transform, and load, right? Similarly, we can also see this in map reduce systems. So there will be one filter which is doing the mapping or extracting the data to some format, and then reduce filter will actually do some accumulation, aggregation, and things like that, right? So we can make use of this architecture in these type of systems. So one of the popular examples is a Kafka type of system, where there is stream of data coming in and that data needs to be processed and moved on to the different systems and so on. So in this type of situation, we can make use of this architecture. We can also see this in command line shells. If you have ever done Unix programming, shell scripting and so on, we can use these type of commands inside shell scripting or directly on the command line as well, where we are passing the output of one command to the next command and then to the next command and so on, right? So this is mainly following the pipeline style architecture as well. Okay, so these are some of the examples for this architecture. Now let's see some trade-offs. So pipeline architecture is quite similar to layered architectural style in terms of trade-offs. It is a simple system. It is type of a monolith because we want to put all the filters and pipes together, and it is a cost-effective solution because of this monolithic nature, right? And the cons come similar to layered architecture again. Deployability is a concern. If you want to change something in any of the filter or a pipe, we have to deploy the whole thing again. Similarly, we have to test the whole thing again. And scalability is a challenge because we cannot scale individual filters to a different scale than the others, right? And fault tolerance is also a problem because it's a linear architecture. So data must travel through all the pipes before it reaches the consumer filter, right? So if any of the filters break in between, the whole workflow is broken. We may have to restart it or handle something in a different way, right? So those are some of the challenges in this pipeline architecture style. Okay, so that's all I had for this pipeline architecture style, guys. If you have any questions, definitely let me know. In the next video, we will look at the next architectural style. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I will see you in the next one. Cheers.